by front face and back face of a uh, polygon. Um, See the side of the polygon which will face into the object interior. The side of the polygon which will face into the object interior, we will call it as the back face. Means the face it is not visible, or the face, the side of the polygon which is visible, or it is outside the object. It is outward the object side, that will call as the front face. So front face and back face of a polygon means the side of the polygon that faces into the object interior, we will call it as the back face. It is not visible, and the visible or the outward side of the polygon, we will call it as the front face. So we have uh, we have two phases, um, front face and back face of the polygon. So the definition, we know the side of the polygon that faces into the object interior, we will call it as the back face, and the visible or the outward side, we will call it as the front face. So how do you identify? How do you identify that with respect to the coordinates? So you know that every polygon will be contained in an infinite plane, which will partition the plane into two parts, which will partition the space into two parts. So any point that is not on the plane and visible to the front face of the polygon surface, we will call it as the front side of the plane. Meaning, see, every polygon will be there within an infinite plane. So we have yesterday we studied about the equation of a plane with this equation: ax plus by plus cz plus d is equal to 0. So every polygon will be there within this plane, which partition the spaces into two regions. 1 second, so many are joining, I think. See, like this, the continuity will not be there. So, um, see, every time when someone is joining, I'll get a beep sound. So that will be like a distraction. So from next class onwards, join before the 5 minutes. Like from the starting of the class to 5 minutes, we'll finish it off this, and then we can continue with the classes. And also in between, don't disconnect from the meeting. Again, the procedure will be repeated. So that's why. So you know that every polygon in a plane is represented within the plane equation which we studied: ax plus by plus c z plus d is equal to 0. So any point that is not on the plane, and that point which is visible to the front face of the polygon, is said to be in front of the polygon or in front of the plane, and thus outside the object. Meaning, so any point which is not on the plane and is visible to the front face of the polygon, so that surface section will be in front of the plane, meaning outside the object. So outside the object, it will be visible. So, and any point that is visible to the back face of the polygon is said to be behind the plane. For example, one polygon is there. One polygon is there. Any point which is in front of this polygon, any point which is in front of this polygon surface, or it is visible from the front surface, it is said to be in the front of the plane. It is said to be in the front of the plane or outside the object. And any point that is visible to the back face, so this is the front face of the polygon, and the part which is not visible will be the back face. For I'll draw this for our understanding. So if you assume this as the front face and the opposite side as the back face, any point that is visible, so there is some point behind this polygon which is visible to the back face of the polygon, is said to be behind the polygon or behind the plane, or inside the polygon or behind the plane. So so that we will call it as um, so what we are talking about, any point that is not on the plane, or which is visible to the front face of the polygon surface, is said to be outside the object, and any point which is visible to the back face of the polygon is said to be behind the plane. So you know that plane equation is being given. So for this plane equation, for this plane equation, um, for this plane equation, if the point is not on the plane, if the point is not on the plane means if any point is not on the plane means if any point is not on the plane means then this this equation will be this ax plus by plus cz plus d will not be equal to 0. So for any point which is not on the plane, we will have this equation ax plus by plus d is not equal to 0. So from this point, so from this equation, from this equation, if it is not on the plane means definitely it will not be equal to 0. This equation will not be equal to 0. So from this equation, we can identify whether whether the point is in front of the polygon or it is point is behind the polygon. So we know that the equation will not if the point is not on the plane means we have this equation ax plus by plus cz plus d is not equal to 0. So now we can identify the point as either the point is in front of the polygon or behind the polygon surface by using this equation. So where if the value of this equation is less than 0 means the point is behind the plane. If the value of this ax plus by plus cz is 0 means the point is in front of the plane. So using these two equations, you can identify whether the point is behind the plane or in front of the plane. So this is with respect to the plane equation. So when it comes to the when you want to find the orientation of the polygon surface in space, so that can be defined with respect to the normal vector. So that can be defined with respect to the normal vector for the plane which contains this polygon. So how this is means, so the normal vector, see, orientation of the polygon surface in a space can be described with the normal vector for the plane that contains the polygon. So the first thing is here you can check one point is there, no one point, you just assume that point. So if the point is coming, if the normal vector point is from the inside of the polygon, so it is from the inside of the polygon to outside of the polygon. Here the normal vector n the normal vector n is pointing in a direction from, it is coming from inside the plane to the outside. So that is from back side of the polygon or the back face of the polygon to the front face. So it is coming from back face of the polygon to the front face of the polygon. So here the normal vector for this plane, is n is equal to 1 0 0, which is in the direction of positive x-axis, which is in the direction of positive x-axis. So any vector which is pointing from the inside of the uh, plane to the outside of the plane and is perpendicular to the plane, x is equal to 1. So that's why n is 100. N is 100 means the normal vector is pointing from inside of the cube to the outside of the cube and it is perpendicular to the plane, x is equal to 1. And also um, these elements of this normal vector can also be calculated by using the vector cross product. Also you can use vector cross product vector cross product to obtain the elements of normal vector. For example, you assume that we have three vertices. For example, you assume that um, there is a polygon which contains three vertices v1, v2, v3. We have three vertices for a polygon polygon, and the object is viewed from uh, outside towards the inside, like it is viewed in this direction. The object is viewed from the outside of the object towards the inside of the object. So now we will form two vectors. One vector is from v1 to v2 and the other vector is from v1 to v3. So if it is a vector means the it will be the vector cross product will be like this. So if it is in one direction and if it is in another direction, the cross product will be in this direction. This is the vector cross product. So the same way, so for example, we are assuming that we have a polygon with three vertices, so vertex position v1, v2, v3, and we are all viewing the object from outside of the polygon towards the inside of the polygon, and we are taking vector 1, we are taking one vector as v1, v2, and we are taking one more vector as v1, v3. So the first vector is from v1 to v2 and the second vector is from v1 to v3. So we can find the vector cross product. We can find the vector cross product n as the difference between v2 minus v1 into v3 minus v1. So this will be the vector cross product. So what this equation will do means this will generate the values for the plane parameters a, b, and c. So this will generate the values for the plane parameter a, b, and c. So uh, using this ABC, we can obtain the value for the parameter d. So if you obtain the values for a, b, c, then you can find the values for d by substituting the ABC value, because you know that ax plus by plus cz plus d is equal to 0. And also this plane equation can be expressed in vector form using the normal n and the position p at any point on a plane by using the formula n into p is equal to minus d. So the plane equation can be expressed, the ax plus by plus d, the plane equation is there, no? So that can be expressed in the vector form using the normal n, and point p is any position on the plane. See, this point p is any position on the plane, which is given by the formula np is equal to minus d. So mm, this is regarding the orientation of a polygon surface. So the next one, what is the next topic? The next topic is uh, fill area attributes. So fill area means filling this area with some pattern or some color like that. So you can fill the specified regions like circles, ellipses, and other objects which are having curved boundaries. So what is this basic fill area? So this basic fill area is nothing but the display style of the interior, how the interior should be of the hollow. See, the first figure is an example of, here the interior is of hollow, here the interior is of solid, and it is the pattern, a tiled pattern. It's a tiled pattern. So what is this basic fill area attribute will do means, so it is the display style of the interior, how the interior should be displayed. So you can display a region with a single color, or you can display a region with multiple colors. See, here it is only a display of single color, but here you are using two colors. One is the light gray and the dark color. So two different colors are being used. And also you can display in hollow style also. The first example, only where you are showing the edges or the boundaries of the polygon. So you can also fill this area. You can also fill this area of a polygon or an object using various textures, various color combinations, various brushing styles, all these things. So for polygon, you can show the edges in different colors, like this edge in one color, this edge in another color, and this in another color, and also the width. So some are having um, with the different, so this will be with smaller width, higher width, like that, and also the styles also, and also you can select for front face, you can have particular color, and for the back face also you can have particular color, width, and style. And also like see, one thing is the fill pattern can be defined in a color array which will contain the different colors for different positions in the array. So this fill pattern can be defined in a color array which will list the different colors for different positions in the array. So then this array which specifies a fill pattern in the mask should be applied to the display area. So the mask will be replaced with the horizontal and vertical direction until the display area is filled with the non-overlapping copies of the pattern. So this pattern we will call it as the tiling. So which you can check here. This pattern, this process of filling the area with rectangular pattern, you can call it as the tiling. Um, See, sometimes the rectangular fill pattern is referred as a tiling pattern. No, it will be predefined. It will contain predefined fill parameters in the system, which we will call it as the hatch fill. So this what I told means the process of filling an area with rectangular pattern is called as tiling. So sometimes there this rectangular fill patterns are available in a system, which we will call it as the hatch fill. Hatch fill. So here also there are two kinds of hatch fill. One is the diagonal hatch fill. This is the diagonal hatch fill, and the second one is cross hatch fill. So hatch fill in two direction like this, one, two. So this example, this is like an example one. See like this. So we will call it as the hatch fill. So it is in one is the diagonal hatch fill and the second one is diagonal cross hatch fill. So after this, after this, the color blended fill regions. So first thing is I'll just explain this example. You just look into the figure. See, um, here, here we'll assume that 0, 1, 2, 3. So 0, 1, 2, 3. So background, this is the background color. This is the foreground color. So whenever you are doing the AND combination, whenever you are doing the AND combination, there is a color here, there is a color here. So the color is getting displayed. So what color, how we will discuss later. So here you don't have any color. Here you have color. Since it is an AND operation, here you are not having any color. So no color, no color. So here also no color. Color is there, color is not there, so blank. So this is the working of AND. So when you perform some AND operations, so likewise OR also. See, color is there, color is there. It is getting pixel is getting deep, it is getting its pixel value. Here color is not there, but color is not there. Since it is an OR operation, so the color is there. So when both the, so it is like here, when both the faces are having the color, so that color will be displayed. If even one place doesn't have any color, it will not be displayed, or it will not be stored as a pixel value. But in this ORing example, even if at least one pattern, if either in the pattern array or in the background array, if it contains a color, so it will be recorded on the pixel value the same way. So what is this? The same way you can check with XOR also. The same way you can check with the XOR also. So whenever both the places contain color, it will not be displayed. Where even if it doesn't have any color also, it will not be displayed. So it is like 1 1 output will be 0 0 0 output will be 0 when it is 1 0 1 or 0 1 1. Same the binary operations, binary and binary or XOR operations. And replace, uh, see, replacements, what it will do means it will just see, it is just replacing this pattern with the background color. So that is the thing with the replace. So now we just studied about the operations. Now we'll talk about the soft fill algorithm. Now we'll talk with the soft fill algorithm. We just spoke about, see, this is just for our understanding how the color is getting displayed. So now color blended regions. So color blended regions can be implemented either using the transparency factor to control the blending of the background and the object color, or using simple logical or replace operation as shown in the figure. So you can check it out. So this colored blended regions is implemented either using the transparency factor to control the blending of background and object color. So the pattern is there. No, the pattern contains the object color, and that will be blended with the background color. So this can be done either using the simple logical operations like AND or XOR or replace operations, or the second method is the linear soft fill algorithm. So what this linear soft fill algorithm will do means it will repaint an area that was originally painted by merging the foreground color with the background color where the two colors are not equal. So see, one thing is this color blended regions can be implemented either using the transparency factor to control the blending of background color and the object color. See, this is the background color, this will be the object color. So you can use the color blended region with transparency factor to control the mixing of this background color and the object color, or you can also use the simple logical operations just like shown here. So what this linear soft fill algorithm will do means it will repaint the area which was painted by merging the foreground color with the background color, but these two colors are not equal. So for this we have one equation. So this is the pixel value. So you just remember this. This is a pixel value, the pixel array or the resultant array. So the color P of each pixel within the area to be refilled is some linear combination. So here they're given this equation. P is equal to TF plus 1 minus T into B. So F means the foreground color, B means the background color. So here T is there now. So we studied one point. The color blended regions can be controlled by implemented by using the transparency factor. So here T is the transparency factor. So here T is the transparency factor, which is having a value from or between 0 to 1. It is having the value between 0 to 1 for each pixel value. For each pixel value, it is having the value between 0 to 1. So if the value is less than 5, if the value is less than 5 means, if the value is less than 5 means, if the value is less than 5 means it is like zero point 0.4 into F plus 1 minus zero point 0.4 will be 0.6. So the background color will be dominant. So if the value is less than 5 means the background color will contribute more to the interior color than the fill color. So this is the fill color. This is the fill color. This is the background color. If the transparency is less than 5 means the background color will be contributing more. The background color will be contributing more to this resultant color region than the fill color. Instead of fill color, the background color will be dominant. So that is what I just wanted to tell. So the equation is given by P is equal to TF plus 1 minus T into B. F means foreground color, B means background color. If the value of T, if the value of transparency is less than 0.5, less than zero point 0.5 means the background color contribution will be more to the interior color of the region than the fill color. So if you want to represent the colors, if you want to represent the color values using RGB, if you want to represent the color values using RGB means we have separate equation. P is equal to pixel of R color, green color, blue color. See, this is the color pixel, or what do we call the pixel value color. So PR for red color. So here we are writing for one generalized equation. So this is PR is for red color, PG for green color, PB for blue color, and F means the foreground color for red, foreground color for green, foreground color for blue. Again, B means the background color for red, background color for green, background color for blue. So like this, if the color values are represented using separate red color, green color, blue color, then the component of this equation PFB, it is represented by PFB, where P is the combination of separate red, green, and blue component, and F is a combination of separate RGB values. So now, how to find transparency? Now for this, how to find the transparency? So for this, the transparency is calculated by what is this? The point pk minus the background color by foreground color minus background color. So this is a formula where k can be red or green or blue. So how to calculate transparency means the transparency formula is given by pk minus bk by um, fk minus bk, where k can be red, green, or blue, and also here also the foreground color is not equal to background color. The foreground color is not equal to background colors. So this is the formula when you are using separate RGB components. And there is one more scenario where there are two background colors B1 and B2. Two background colors are there and only one foreground color is there. So front color is only one and background color we have. So now for that the formula will be P is equal to T naught F plus T1 T naught F plus T1 background color 1 plus uh, difference of 1 minus T naught minus T1 background color 2. So um, so this is the formula when you are having two background colors which is to be mixed with one foreground colors. So the same way even you can have three background colors and one foreground colors, or two background colors and two foreground colors. So for this you can write the appropriate formula. So this is regarding the color blended fill regions. This is regarding the color blended fill regions. um, so the next thing is the scan line algorithm, the scan line polygon fill algorithm. See this algorithm is very important one and the simple one. So how means, so this scan line algorithm, what it will do means it will just scan this polygon line by line and it will fill the color for that polygon. So so first thing is scan line what how this scan line algorithm means. So it is like, for example, it is like scanning like this, scanning scanning the polygon. So I'm just giving some spaces, so it will be scanning like this, so it will be scanning like this. So it will scan the algorithm. So what the scanline algorithm will do means, first it will scan the line in this direction where y is equal to constant. So y is equal to constant. So this will scan the line. What it will do means, here we have polygon. So here we have polygon. So one line will be scanned. So after that, it will find the intersection of this line with the polygon. After that, it will check the pixel. It will check the pixel, and in between this, the pixel, these values will be sorted in ascending order, and the boundary between these two will be colored. Like it will be filled with some color. Again, it will scan one line. It will check the boundary, do some color. Scan the line, do some, find the boundary, do the coloring. So this is a simple procedure. So now we'll go with, so this is how the algorithm works. What it will do means, it will scan a line, it will find the boundary of the line which is interacting with this polygon. In between that, it will color. Like this the process will do. So what is the scan line algorithm? So the scan line fill of a region is performed by first determining the intersection position of the boundaries of the fill region with the screen scan line. Meaning, see here I'm drawing, this is the screen scan line. This is the screen scan line. This is the screen scan line. So the fill of a region is performed by first determining the intersection position of the boundaries of fill region. So this is the region which we should fill with some color. So this we'll call it as fill region. So first thing is we should find the boundaries of the fill region with with the screen scan line. So what is the intersection boundary? So here the scan line is getting intersected at this point, and it is getting intersected at this point. After that, it is getting intersected at this point, and it is getting intersected at this point. So these are the four places where the scan line is getting intersected. So this is the first step. So first step is find the points or the intersection points of the scan line with the boundaries of the fill region. Then then you need to fill the colors. Then the colors will be applied to each section of the scan line, each section of the scan line which lies within the interior of the fill line or within the interior of the fill region. So here you should apply color to this part because this line is inside the polygon. You should neglect this part because this line is outside. This line is outside the polygon. Again, for this area also, you should apply the color because it is inside the polygon. The next step is the fill color will be applied to each section of the scan line which lies with the interior of the fill region. So this is interior of the fill region. You can apply the color. So how to apply the color? How to apply the color means so how to apply the color means here for in our example so we know that this pixel this pixel this value and this value. So so in our example the line is intersected at x is equal to 10, x is equal to 14. So one point line is intersected at x is equal to 10, x is equal to 14, x is equal to 18 and x is equal to 24. So since the line is intersected, the first thing is what we will do means we will find the intersection pair. So we'll find the intersection pair, and for this each intersection pair we'll apply the color. So the scan line in our example, what we will do means the color will be applied from x is equal to 10 to x is equal to 14, and for the pixels from x is equal to 18 to 24, like x is equal to 10, x is equal to 11, x is equal to 12, x is equal to 13, x is equal to 14. Then x is equal to 18, x is equal to 19, x is equal to 20, 21, 22, 23, 24. Like this we are applying the color. So whenever the line passes through the polygon, the same procedure will be repeated. So this is the working of scanline polygon fill algorithm. So what it will do means a scanline fill of a region is performed first by identifying the intersection position of the boundaries of the fill region with the screen scan line. After that, then the fill colors are applied to the each section of the scan line that lies within the interior of the fill region. So this is how the scan line will be performed, or the color will be, or the scan line fill of an algorithm will be working. So this is how it is working. So but this will work for, but there are some special cases, but you just look into this for a minute so that I'll just explain the special cases. So what it is doing means, you just understand in simple terms. I'll draw a line, so I'll just calculate the boundary. Okay, so if if this line is inside the polygon, if this line is inside the polygon, so the in between these two intersections, all the positions will be painted with some color. So that is the working of this algorithm in simple terms. So just look into this for a minute. After this, we'll check the special cases. And one more thing is, like, see here, the coloring is done from left side. Coloring is done from left hand side to the right hand side here. So you can check that first the coloring is performed from x is equal to 10 to x is equal to 14, and then from the coloring from x is equal to 18 to x is equal to 24. The in between positions from left side to the right side of the polygon. So this is regarding the line is passing through the edges of the polygon, and you're painting that. There are some special cases. So there are some special cases um, which you should consider. The scenarios can be like, whenever whenever the line passes through vertex, so whenever the scan line passes through vertex, so in our example, the scan line y dash is passing through a polygon where it is passing through a vertex 2. So here how many edges it is passing? One edge, two edge, second, third, fourth edge. So the scan line y dash is intersecting with four edges and one vertex which is given by the name 2. Whereas the scan line y is passing through this point. It is passing through this point where it is intersecting with 1, 2, 3, 4, and 5. So it is intersecting. It is also passing through 5 edges and one vertex by the name 2. Um, So here you can understand that whenever the scan line is passing through a vertex, whenever the scan line is passing through a vertex, it is passing through two edges, edge 1 and edge 2. So whenever the scan line y dash is passing through a vertex, it is intersecting between two polygon edges at that point. So here even number of edges and even number of edges. In our example, in the second example, odd number of edges. So the scan line y dash is intersecting with even number of edges, and the scan line y is intersecting with odd number of edges. So these are the special cases. These are the special cases which you should know how to handle. So one thing is like how can we distinguish between these two cases means um, how can we distinguish between these two cases means, see, for the scan line y dash, you know that two edges are above the vertex only. See this two edges which I am marking now with 3 dash. So these edges are above this point called 2. So, so thus, if a vertex has an edges on the opposite side of the intersecting scan line, uh, then the scan line should just count this as one boundary intersection point. So since we know that this vertex 2 has edges which I have named it as 1 and 2 on the opposite side of the scan line. So it is on the sorry, it is on the same side only. No, okay. It is there on the scale. It is there on the okay. See for this y dash, the two intersecting edges are both. See the two intersecting edges are both are above the scan line only. Above the scan line only. So in this case, you can just consider the points like this. You can just consider the points like this: 1, 2, 3. But in this case, if the vertex has edges on the opposite side, see, one one edge is on above the scan line and one edge below the scan line. So in the second scenario, if we have edges on the opposite side of the scan line, then um, then it should consider only one boundary point, meaning 1, 2. This is one point and this is another point. So like this. So this is outside. This is outside the outside the polygon. So this is outside the polygon. So we should be careful whenever the line passes through vertices. So for the scan line y dash, it is passing through a vertex 2 where both the edges are on the same side. So both the edges are above the scan line. So in that case easily you can color the region between those 2 points, 1 to 2 and 2 to 1. But in the second scenario, um, we have vertex which contains edges on the opposite side. One is above the scan line and the other one is below the scan line. So if that is the case means, uh, if the vertex should be counted as only just one boundary intersection point. So see here means here two boundary intersection point, 1 and 2, 2 and 1. But for this example, only one boundary intersection point, 1 and 2 only. You are not considering 2 and 1 because this 2 and 1 is outside outside the polygon. Did you get this point? Did you get this point? Did you get this point? See, this only part is this part. This special cases you should be familiar. So did you get this point? The special scenario. Yes or no? See any response? See, one thing is, see, from the difference only, let me clear this point. See, by looking at this diagram only, you can get to know. See, by looking at this diagram only, um, you can understand since this point is inside, and two edges are above the scan line, you know that this line will be inside the polygon, so this part has to be colored. But here in the second scenario, when the line is passing through this vertex, one edge is above the mm, vertex and one edge is below the vertex. So this will lie inside the polygon, whereas this will not lie inside the polygon. So the second part should be discarded. So that is what. So from looking at the scan line only, you can decide. So the for the scan line Y, the two edges are sharing a vertex. Which are on the opposite side, of the scan line by one above the vertex 2 and one below the vertex 2. So in this case, but for the scan line y dash, the intersecting edges are both the edges are above this only. See whether you are understanding this or what. See the special case only which should we should see whether you understood this, the special case. Yes or no? See if the special case is clear. So okay, since it is already time, see you just remember, since you just remember 2 points. We'll repeat this again in the next class. So see, both edges are on the same side, then this will be counted as the boundary part for filling the algorithm. If both the edges are on the opposite side, one above and one below the scan line, then only one boundary point will be considered and the second part will be discarded. So just remember this point. In the next case also, we'll start with the special case. The normal one, no problem. Normal part, no problem. Scan the line between the intersection of the boundary, color that. That's all. So this is regarding the general scan line filling, polygon filling algorithm. Again, we'll talk about the special cases. Once you're clear with that, we can proceed with the next concepts. So I'll stop the class now.